Good morning, everyone. We've got a great morning of tutorials on some really cool topics today. About things related in some way to outflows or also visualization, since this week is the Viz week. I also wanted to highlight this awesome image that is in the background here for our Outflows week, produced by Evan Schneider, from the Seagulls simulations using her Choya code. Really amazing high-resolution simulations showing outflows into the CGM and the impact on the CGM. So some great papers coming out of that. And Evan is also giving one of our tutorials today on mass loading. All right, so today's tutorials, we have 3 awesome tutorials. We will start off in a couple of moments with Joe Burchett talking about how to visualize the circumgalactic medium in your web browser using his new CosmoVis tool. And not just visualize, but do some really cool data exploration of simulation data that gives you a lot of intuition for how the CGM behaves. But I'll leave it to him to discuss that. So as well, I'll just go through all of them. Our next one at 8:40 will be, as I mentioned, given by Evan Schneider on mass loading in outflows. And then at 9:20, we will have one on absorption line profile fitting. Primarily, Marie Lau will be giving that, but then she'll be presenting one method or a couple of methods using some programs, and then other programs for doing this absorption line fitting will be provided by Joe and by Rongman. So should be really cool. And let's move over to our tutorials, starting off with one from Joe. Are you around, Joe? Oh, there you are.
Yes, thank you. Okay, so yeah, thanks Cameron, thanks to Jess, Mark, Ben, all the organizers for just putting together an incredible workshop here and really making the most of this rather unexpected virtual venue. It's been great, and it will be great for another 3 weeks. So it's my absolute pleasure to present today in sort of a world premiere of sorts. A project we've been working on for about the last year or so called CosmoVis. And so how this will work, I'm going to demo the software, and then we'll go into breakout rooms. I want to leave enough time to make sure and give plenty of time in the breakout room between this tutorial and Evan's excellent tutorial, I'm sure, to come. So please do follow me into the breakout room if you would like to accept what I believe will be an irresistible offer. Okay, so CosmoVis, this is a project that I've been leading, as I said, over the past year or so, and we've been fortunate to have an incredible team. This is a truly interdisciplinary collaboration. First, I'd like to highlight our lead developer, David Abramoff, who has really done so much of the heavy lifting in terms of software development and researching visualization and rendering methods. And so a big thanks to him. He's here today, and he will join us in the breakout room to answer any more technical questions you may have about the underlying software. Oscar Ellick, who is, I should mention David Abramoff is a graduate student in the computational media department at UC Santa Cruz. Oscar Ellick is a postdoc at UC Santa Cruz in the same department, and he has been incredibly valuable as a resource. He's an expert in graphics rendering and 3D printing. Angus Forbes, who heads up the creative coding lab in the computational media department at UC Santa Cruz, who joined us on Monday and will be joining us for the visualization after party today. And lastly, our very own Cameron Hummels, who without whom this would really not have been able to be where it is today. So a big thanks to Cameron for being an incredible resource for all things Trident and YT, both of which CosmoVis heavily relies on. So, key question, what is CosmoVis? CosmoVis, and just so you know, there's some teaser images of CosmoVis, from CosmoVis, here on each of these pages. CosmoVis is a web-based interactive visualization and analysis tool. And essentially, what we're doing with CosmoVis is serving up, for now, cosmological hydrodynamical simulation data. And I say for now, we are looking to move into the realm of zoom-ins and such. Currently implemented are a couple of volumes from the Eagle simulation, and we will soon incorporate Fire, as well as Illustris TNG, and hopefully more. CosmoVis will be released to the public as not only an analysis tool, access to the web, but also all of the underlying software will be open source. And so realistically, this is probably looking at second quarter of this year, but everyone here today will get a chance to check it out. And so who is the CosmoVis audience? That is you, your research collaborators, your students, your neighbors, your family. This is really intended to be intended for mass consumption. So hopefully a little bit of everyone can get something out of it. And just some of the technical details. What makes CosmoVis run? Well, there's basically two parts. There is what happens within the web browser. So this is using JavaScript libraries to render in a 3D environment in two different ways, through volumetric rendering, in which we project the gas and dark matter from a simulation with customizable opacity, color mapping, etc. And also particle data, or what we visualize as particles, which would be stars and black holes within galaxies. And all of this is customizable on the fly. On the back end, we have Trident running on top of YT, of course, with Amazon Web Services cloud computing. So this is handling some of the more computationally intensive tasks that really we wouldn't want to offload to a web browser, such as generating synthetic spectra through Trident and doing the line of sight physical attribute mapping, as we'll see later. So just some of the motivation for why we wanted to undertake this this project. And so what I have here is sort of a workflow of how one might use simulation data, say as an observer, as I primarily am. There's all this great simulation data. There's been a lot of tools such as YT, Trident, and many others that individual groups have developed for their own simulation data. And so in terms of actually using these data to bring them to bear on our observational results, to try to glean scientific insight, it's really not quite as straightforward a process, at least I found, to do that. So in addition to acquiring whatever simulation data set you might want to compare to, be it many of these cosmological boxes that have been released to the public, like Eagle, Illustris TNG, there are independently sort of tools to analyze those, such as Trident, for example. If I want to compare some of my HST cost spectra to those that would result from the models. So it's sort of a convoluted process to come out on the end for basically the lay user. So we wanted to encapsulate a lot of these analysis, data acquisition pieces of the workflow into sort of one unified environment, and that is what CosmoVis is all about. So the idea here is one can go straight to CosmoVis, explore, manipulate the cosmological simulation, and then get out some physical attributes or even synthetic data that can then be directly compared to observations. So I know what you're thinking. This all sounds great. You're going to need people to use this thing, right? The audience is me. So if you're a big fan of the Judds, like I am, 3 words come to mind. Why not me? Well, everyone here is invited to become a beta tester to help steer development and the future of CosmoVis. So we just invite you to please complete just about a 30-minute user study on your experience with CosmoVis, because this will really help not only steer the development, but this is a visualization project, and so we really want to research the human data interaction piece of all of this. So also join the new Slack channel that I have created called Halo 21 CosmoVis, and we can talk all about CosmoVis there, share some interesting results maybe you found with it, and so on. So without further ado, just switch over here. Okay, so whenever you load up CosmoVis, this is essentially what you are going to see. So this is the Eagle 12 megaparsec box, and we have a number of attributes that are visualized here. There is gas, dark matter, and stars, as I mentioned in the slides previously. So I can interactively turn on and off each of these layers. So I'm just going to turn off the dark matter. Now we're left only with the gas layer. And I realize the video might be a little choppy, so I'm just going to optimize here.
You stop sharing.
There we go. Okay, so so as I was saying, we can turn on and off each of these layers within CosmoVis, and here I've turned off dark matter, turned off gas, and here we just have the stars from the individual galaxies. You can turn on just the dark matter so you can see the cosmic web filaments and such, and just the dark matter distribution. And this is just the gas, as I was saying. So you can already kind of see some interesting phenomena that have been going on over the course of the evolution of this box. This is a redshift 0. You can already sort of see some interesting things that we'll actually investigate in a little bit more detail here in a bit. So I just want to walk through the interface of CosmoVis and demonstrate some of the features that we have here. So we're going to focus mostly on the gas. So you'll see me turn off dark matter for the majority of this demonstration. So here we just have the gas layer. As I mentioned, this is the 12 megaparsec box of Eagle. And I want to now just use the data selection tool here and just kind of focus on some various regions of the simulation. I've turned on the axes helper, so you can probably see down in the corners along the box, we have the color coding corresponding to various axes here, so I can slice the data. Look at a particular region, just slicing along these axes, color-coded above the respective sliders for each axis. So you can kind of zoom in on an individual region. So this is sort of the coarsest grid resolution. This is what you'll see when you first open up the application. This is only a 64 cube box, so a fairly coarse resolution. And we have under the hood here a couple, 3 actually, resolution levels per simulation volume. So this is now that same volume we were looking at, sliced from the big 12 megaparsec box. Now just focusing in on a couple of galaxies here. Apparently has some nice super bubble action in their CGM. So going back to our layers panel, I'm going to customize the visualization a little bit. So color coded here is the temperature of the gas, and I have a color range picked here of about 3.10 to the 3.7 K up to 6.75 Kelvin, where the redder values, the redder colors are corresponding to the hotter temperatures. And I have the all gas below 3.7 Kelvin to the 3.7 clipped out. So you can see a little bit of difference there. Just focusing in on the temperature range from about 10 to the 4 on hotter. So I visualized temperature or color-coded temperature, but we can also look at other attributes. This is the metallicity in the same environment. So you can see a lot of interesting substructure that's actually quite different than that we see in the temperature. Entropy. I'll now go back and look at the full volume. So some interesting structure along shock fronts and such with the entropy data. Okay, so let's now focus on a specific region of parameter space. So now I'm going to just focus on the so-called warm-hot medium. So this would be about 10 to the 5 Kelvin to 10 to the 6 Kelvin. And so I can clip out everything that is below and above this temperature. So, so you can see a lot of the hot gas that's sort of in the, a lot of the hot gas that's right in the center of the halo has now been, is now missing. Turn off the dark matter, get a better view here. Okay, so let's go back and view this sort of full range here. We'll go back to the course resolution. So just kind of demonstrate a workflow one might use when interacting with the software. We go back to the full volume. So as I said, this is the course's resolution, and this loads very quickly and enables you to get a nice overview. It's obviously not quite as much structure as you would see in the higher resolutions, but you can quickly sort of go between the 12 megaparsec boxes we were just on to the 25 megaparsec. Just a second to load here. Turn off dark matter. Take another look at the entropy. So you really see some nice shock fronts along the CGM and IGM. Go back to the 12 for a second. And I mentioned that sort of highlighted these couple of galaxies here earlier. have very clear evidence of some past feedback activity. Let's home in a little bit higher resolution so we can see a little bit more substructure. This is not only in the temperature, of course, but these other values. But let's crank up the resolution even further and do a little bit more in-depth study on this particular system. Should take about between 30 seconds and a minute to load from the web. I'm running this locally here, so it's just to mitigate any issues while continuously or while simultaneously running Zoom. Okay, so here you see even more substructure in the temperature, but I want to get a little bit more quantitative with the analysis, and so I can draw a skewer anywhere through here. So let's just go right through this little bubble area and request some data along the line of sight. So this is all generated on the back end with Trident and YT. Trident is taking the physical conditions of the gas along the line of sight and not only returning those, but also going to provide us some ion data. Okay, and here we are. So now you see the temperature structure along the line of sight, going from sort of the cool phases out in the IGM here. As we enter the CGM in this bubble area, we get to the hotter regime and around 10 to the 6 Kelvin, and then going back into the cooler phases once we leave the CGM. So this is temperature. You can look at a number of quantities: entropy, metallicity. So this is about a tenth solar for the most part. Quite a bit of relatively metal poor gas actually in this bubble. And then we can get ion column densities. So this is a fairly low H1 column density through this line of sight. Have a smorgasbord of ions here. Carbon 3. I like neon 8 quite a bit. So you can see the column density in each cell along the line of sight, and then the cumulative column density of that particular species. So oxygen 6, we like oxygen 6. We also like oxygen 7, oxygen 8. So basically any of these ions, you can get a cumulative column density as well as see the distribution of that particular ion along the line of sight. We'll go ahead and draw another skewer between these two bubbles. Get this data. And you can see the two temperature peaks where we are going through the bubble region, the outflow, the region of the past outflow from one galaxy to the next. So lots of fun one can have here. Can go back and since we have this higher resolution of the volumetric rendering, let's take a look at the metallicity. You see the metallicity structure, the morphology of the metallicity distribution is actually quite different than the temperature distribution, which I find to be interesting. Okay, so with that, I do want to save some room to step into the breakout rooms. Like I was saying, everyone here is invited to be a beta tester. Everyone, as long as you complete the user study, help us out on the development side as well as from the visualization standpoint, HCI standpoint. So please join me in the breakout room. There I will actually give you the IP where you can go on and you can play with the tool, and we can get started on the user study if you like. But with that, thank you.
Awesome. That was super great, Joe. Really could be a game changer for a lot of people in terms of how they interact with the simulation data and how they probe it. There are a number of questions that were raised in the chat, as well as Drummond has his hand raised. But I think for the purposes of making sure Evan gets a chance to do everything in 6 minutes for her presentation, we will move Joe and Angus and David and everyone who's interested in talking about this awesome tool to a breakout room. So if you go into the breakout rooms, you can click CosmoVis, I believe. Recall, though, that we will start Evan's presentation at 8:40 in 6 minutes or so. So it's a trade-off. The presentations are recorded. The breakout rooms are not, if that helps your decisions. But yeah, super great, Joe. Really cool work.